Hey folks, welcome to Military Forces Unleashed. What are collaborative combat aircraft and why is the Navy suddenly prioritizing their development? Collaborative combat aircraft, or CCAs, are uncrewed, modular, interoperable, and versatile drone platforms designed to act as loyal wingmen to crewed fighter jets. They are intended to be persistent, lethal, and agile force multipliers capable of operating from aircraft carriers. While the Navy initially took a wait-and-see approach, focusing on the MQ-25 Stingray tanker drone, they have now issued a flurry of contracts for CCA conceptual designs. This push forward is driven by the desire to maximize operational flexibility, address current and emerging operational gaps, accommodate elevated risk profiles for uncrewed systems, and reduce risk on crewed platforms by enabling fourth, fifth, and complementing sixth-generation fighters. Essentially, CCAs offer a cost-efficient way to expand naval aviation capabilities. Which companies have received contracts for the Navy's CCA development, and what are their specific roles? The U.S. Navy has awarded contracts to 5 companies for CCA-related work. Anduril, Boeing, General Atomics, and Northrop Grumman are contracted for conceptual CCA designs. These companies have existing relevant designs, such as Anduril's YFQ-44A, or Fury, General Atomics YFQ-42A, derived from XQ-67A, and Boeing's MQ-28 Ghostbat. Lockheed Martin, on the other hand, received a contract specifically for work on a common control architecture, building on its existing role in developing the Navy's MD-5 Unmanned Carrier Aviation Mission Control System, or UMCS, and MDCX Autonomy Platform. How do the Navy's CCA efforts compare to those of the Air Force and Marine Corps? The Navy has explicitly stated that it is in the follow of its sister services, the U.S. Air Force and the U.S. Marine Corps, in developing CCAs. The Air Force is leading in the development of the actual air vehicles and their autonomy for mission execution, having already progressed to Increment 1 with specific designs like the YFQ-42A and YFQ-44A. The Marine Corps is focused on developing manned-unmanned teaming capabilities, particularly with platforms like the F-35. The Navy's initial focus was on integrating the MQ-25 Stingray into its fleet before pushing forward with its own CCA conceptual design efforts. What are the key characteristics and benefits the Navy expects from its future CCAs? The Navy's vision for its future CCAs includes several key characteristics and benefits. They are envisioned as uncrewed, modular, interoperable, interchangeable, and versatile platforms. These drones are expected to be persistent, lethal, and agile force multipliers, capable of carrier operations and both cost-efficient and mission-effective. Crucially, they aim to maximize operational flexibility, address current and emerging operational gaps, accommodate elevated risk profiles, implying they might be more expendable, and reduce risk for crewed platforms. They will enable 4th and 5th generation fighters while complementing 6th generation fighters. What is the concept of a common control architecture, and why is it important for CCAs? A common control architecture refers to a standardized system for commanding and controlling uncrewed aircraft. Lockheed Martin's contract for this aspect is crucial because it ensures interoperability and seamless integration of various CCA platforms into the existing carrier air wing. Lockheed Martin's Skunk Works MDCX Autonomy Platform is already a program of record solution for the Navy's Unmanned Carrier Aviation Mission Control System. This unified architecture will provide uncrewed vehicle autonomy, mission planning, and command and control (C2) capabilities in a secure package, allowing for efficient management of diverse CCA types. What challenges remain in integrating CCAs into naval operations, particularly regarding trust and training? Significant challenges remain in fully integrating CCAs into naval operations. These include figuring out the specific platform designs, how they will integrate into the air wing, and how they will be used for maximal advantage. A major psychological hurdle is building trust between human pilots and autonomous systems. As an instructor pilot noted, the wings on your chest signify trust and predictable behavior in human wingmen. Replicating this trust with collaborative autonomy requires standardized training pipelines and a deep understanding of how autonomous systems will behave in repeatable and consistent ways, especially in combat scenarios. How have some of the contracted companies already demonstrated relevant capabilities for carrier-based drones?
Several contracted companies have already showcased relevant capabilities. General Atomics has been pioneering a modular baseline concept, allowing different drone types to be built around a common chassis. Their experimental XQ-67A and YFQ-42A designs demonstrate this, and they unveiled a carrier-based Gambit 5 design. General Atomics also has extensive experience with carrier-based unmanned aircraft, having launched their Mojave demonstrator from HMS Prince of Wales and the South Korean amphibious assault ship Dokdo. Boeing has previously shown a carrier-based variant of its MQ-25 Ghost-Bat, originally developed for the Royal Australian Air Force, which the U.S. has shown strong interest in due to its AI-driven autonomy and modular design. Northrop Grumman, a former leader in carrier-based UCAV development with its X-47B demonstrators, is leveraging its deep experience in naval aviation and advanced autonomy, including its Beacon autonomy ecosystem. What does the Navy mean by CCAs potentially being consumable?
The concept of CCAs being consumable suggests that some of these drones could be cheap enough to be expended during operations. This implies they might be used as one-way attack munitions, sent on high-risk missions where their loss is acceptable, or utilized as targets for training and test and evaluation activities. This idea highlights the Navy's focus on cost efficiency and the ability of uncrewed platforms to accommodate higher risk profiles, thereby preserving more expensive crewed aircraft and their pilots.